So we're just going to have one grand party and finally burn out my graphics card so I can give myself an excuse to get another one. Oh, and there's a tiny one right there. Okay, let's see how this plays out. Hello, everybody, and welcome back to Universe Sandbox 2. I believe our first Universe Sandbox video of 2019. Maybe we did one in January. I think the first one that I can remember in 2019. We have some new updates in Universe Sandbox 2, so it's time for some more science. They updated the galaxies. Let's see, what's new? Beyond the Milky Way. This update adds some brand new galaxies that are much more interactive, accurate, and varied, making it easier than ever to create and customize on a galactic scale. Use the add tool to procedurally generate a spiral, elliptical, or a regular galaxy and add it to any simulation. So I remember I've messed with galaxies maybe once or twice, maybe in videos, but it was less than impressive. I'm just going to create a new simulation. Add galaxy, random spiral galaxy. Does it look cool now? Well, that looks about the same, unless like the animation is all weird. Nope. Oh, seeing some movement. There we go. Okay, so we're seeing some stuff move around here. I can't tell if that is new or old, but we're seeing like a bunch of stars or something. Can I click on these individual things moving? No, not really. Right, let's just do the Milky Way. So add the Milky Way, and that's what the Milky Way looks like now. I need some kind of comparison. I don't know if I can look up some archive footage of this game of what the galaxies looked like before, but I remember there being all sorts of weird red dark matter dots. I think they were just called dark matter. But this definitely looks a little bit more detailed. So the galaxy has a lot of parts that animate now. So what if we let's keep it looking like this for now, where you don't really see the spinning. We will try and simulate our own Andromeda Galaxy collision. I'm hoping that the Andromeda Galaxy is going to collide with the Milky Way at some point, because I just used the launch feature. Okay. And maybe it will get closer. I think the Andromeda Galaxy is going to get closer. Yep, it totally is. Okay. Slow that down. Slow it down. So they'll start approaching. And now the big question is, how interactable are these galaxies now? Are we going to get this? I want a better picture of this. Hold on. Huh. Well, that happened a lot quicker than what I would have liked. Ooh, the possibilities. Milky Way number 1. And then we got Milky Way number 2. So these are like kind of galaxies orbiting galaxies. Like we just kind of created some binary system. Galaxies still work the same way as stars when it comes to mass. It's just a big massive object, so they should be able to orbit each other. It might be a little irregular because it's more of a disjointed object, if you want to call it an object, a group of objects. But you know, as a collective, the barycenter, the center of mass. It's center of mass. Like it has a center of mass. So really just pay attention to the center of mass. You have Sagittarius A right in the middle there. That's the black hole in the middle of our galaxy. But they should be spinning around each other. This is getting funky. Oh my god, there's like not one central thing I can click on. It's actually really hard to focus on these things. I'm guessing it's probably best just to look at these things with free cam. Okay. So they're pulling off from each other. And they more so just kind of missed. Or they are just straight up orbiting around each other, and now they're just going to chase each other for all of eternity, and that's the big dance we're going to have. And our own galaxy is just going to work on in cycles. I want to launch this Milky Way galaxy along the 1.92 Milky Way point right here. Okay, press that. And then we're going to launch it along the other 1.92 Milky Way. There we go. So that way they will meet right in the center and collide with one another as best as they can. But even like with my mouse movements, like this will likely be slightly off. Let's just see what happens when we have two Milky Way galaxies colliding in front of each other. So it's hopefully in a perfect situation going to be a head-on collision. Okay, we're currently at 10 years per second and you still see this thing barely moving. Lifetimes are going and you see this thing barely moving. Oh my god. Okay. 700 years per second. Wait, I think I might have saw a flicker in that Milky Way. Okay. 3,000 years per second. Nope, absolutely nothing. Okay, we're starting to see some movement at 160,000 years per second. Let's get rid of the trails. Okay. We'll just watch this beautiful, beautiful dance happen. Speed it up, speed it up, speed it up. I'm hoping they're going to collide into each other. It seems like it's going very, very slow. Okay, slow it down. Okay, slow it down, slow it down. I want to watch this thing happen, and we are going to take notes as this happened. What do we observe? We're observing two galaxies sucking each other up. Or actually, they're just going to phase right through one another. I mean, the thing about a galaxy collision is that there's so much empty space in between all of the stars is that it's actually very unlikely any one star is actually going to collide. So they really just kind of go around each other. I mean, gravity will influence each other. Ooh. Wait a minute. Wait a minute. Did we lose the black holes? I mean, I'm going to assume maybe we lost the black holes and everything is just dissipating now. What is that floating out there? It looks like a cube. Something, there's like an escape pod that just went off into space. I don't know if you guys could even see this in the video. Well, maybe you'll see it in a second. Wait, put that in the background. Oh, I just totally lost it. So we're going to have 4 galaxies hopefully colliding into each other at roughly the same point, you know, to the best of my ability. Oh my God, this is so unrealistic looking. I mean, we can go ahead and have 6 galaxies and go in, you know, in 3 dimensions here, but we'll stick with 2 dimensions for now. So 4 galaxies all rushing towards one another. In the center, I'm gonna guess it's probably gonna do that same poof thing again, but I do like the idea of like some weird looking dance happening. But maybe it's all about just, you know, having them collide in random points, and that's where you get the weird dances happening. If 2 black holes just collide right into each other, I'm guessing they just blow up, and you break physics, and they just delete from the game. Why do I feel like the inner ones are moving a lot quicker than the outer ones? That's totally happening. Why is the top one lagging behind so much? I mean, I guess that's okay, but we have 3 at least right now colliding into each other, and then whoosh. And then one kind of survives a little bit longer than the other because the bottom one was a little bit further away. And now it's going to move on to the top one and they're going to interact. Okay. I mean, that was kind of unexpected. I mean, it probably should have been expected, but they kind of just more so missed each other. And now we just have these partial messed up Milky Way galaxies. And then this one is also just totally messed up. Yeah, that's what you expect. When two big balls of yarn collide into one another, well, they just turn into more messed up balls of yarn. Large Magellanic cloud. Let's just spawn these. They're just going to be static. We're not going to be launching anything. We're just going to make a mess and probably fry my GPU because you already see that frame rate dropping. Okay, let's go. And then speed this up to millions of miles time second per second. Timey-wimey, wiggly-wobbly, boop. What is time? Time is nothing. Oh God, something just got sucked up. Okay. Well, here we have a bunch of helix fossils dancing in the wind. Actually, they're all kind of spinning around. And then whoosh, 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 whoosh. And then 2 survive to be oscillating for all of eternity. I mean, I guess we just have a bunch of stars floating around, but they're also spread out now. You don't really notice. I guess you can kind of say that's what happened. The galaxy breaks up. Here's a cluster of stars. Here's a cluster of stars. Here's a cluster of stars. I mean, the big question is, will they eventually regroup? Probably not. But I would like to think that in reality and physics, outside of a computer-programmed simulation, they would probably eventually regroup because it's a bunch of emptiness, and the nearest massive object, even if they're millions and millions and millions of miles away, there's still a gravitational influence. Even when something is millions and millions and millions and millions and billions of miles away, it's still there to a degree. It's like an infinitesimal amount of gravitational influence, but it's still there. It never goes 100% to 0. And it works for objects of all mass, even 2 people. So you actually are gravitationally, you actually are attracted to people in real life. You have your own gravitational influence. Another person has their own gravitational influence. It's incredibly tiny, but it's still there. And there's a mass component and there is a distance component, and it's math. It's math. For example, 2 baseballs Very, very tiny. Okay, we got to really zoom in on. Okay, I think we just lost the baseball. And we're just going to have another baseball spawn right here. The baseball is orbiting the baseball. How can that be? The baseball's not a planet. The baseball's not an asteroid. The baseball just became a bigger baseball. Let's see here. What's our time step here? 1 hour per second. But let's go at 1 second, roughly 1 second per second, or even 20 seconds. 10 seconds per second. So this is 9 seconds, 10 times as fast as reality. And you can see that you really can't perceive anything happening. And you wouldn't perceive anything happening even down on Earth, because then you have friction. Is it kinetic friction? Or it's coefficient of static friction or static friction? It's called static friction that is holding you in place from being pulled into other objects of mass. But since you're in space, since you're in a vacuum, that static friction is gone. There's nothing stopping these two baseballs from influencing each other with gravity. The force is incredibly small, but it's still there. So it's going to take a really long time for the balls to actually accelerate. And then once they've accelerated, you'll start seeing some velocity. I mean, this is 8 minutes per second, about 8 minutes per second in time step of just, fast forwarding, where you're finally beginning to see some kind of movement between the two baseballs. I think a baseball is probably about the biggest. There's a bowling ball. I think everything will probably just end up crashing to the bowling ball. Let's see. Yeah, everything's just gonna crash right in there. Boop. Or maybe the bowling ball will just fly out into space. Nope, it's definitely going to pull in the teapot. The teapot really wants to go over to the baseball, to the bowling ball. Or not. I mean, I guess a teapot is a little bit heavier than a baseball, so it managed to break out of that gravitational influence. Although, that's not correct. There is still gravitational influence, but the orbit, broke out of orbit. Now it's not the dominant gravitational influence. There's some other gravitational influence, probably the rest of the universe, that is pulling on this teapot harder than this bowling ball, which is resulting in them flying away. That or it's just a high velocity. It's been a long time since I've taken physics. Anyway, galaxies is the point of this. So now we have orange galaxies. Is this all we got? Random, irregular galaxy. Boom. Well, that is a big... Hold on here. I spawned in that. And then I spawned in that. Well, let's do another random one. Boom. Well, that's not so random. How about this one? Boom. Okay. Ooh, that's a smaller one. That's a big one. That's a big one. That's a medium one. That's a medium one. That's a chunko. Oh my god. Random elliptical galaxy. Let's do this one. Let's go for a spiral one. Okay. So we're just going to have one grand party and finally burn out my graphics card so I can give myself an excuse to get another one. Oh, and there's a tiny one right there. Okay, let's see how this plays out. Oh my god, you can see the frame rate. 700 years per second. Here we go. It's going to start moving now. Okay, we're now going at basically a million years per second. I just realized all of these random names too, all randomly generated names. Uar Arato Mnyorsak Nustapai. I do not touch her. I did not touch her. I did not touch her. I did not hit her. I did not. Oh my god, this is atrocious. Speed it up, and then whoosh. And then of course, as predicted, Arato is the big winner. It managed to keep its whole body while everything else just disintegrated. Okay, let's do something ridiculous at like 2,000 kilometers per second. So we're gonna have a galaxy just going absurdly fast, blowing right through the Milky Way before it can even do any kind of weird influence. Holy crap, and those are the trails of that right there, and that actually kind of looks cool. It just looks like a big laser going through the Milky Way. And okay, and then shoot there. Did that do anything? It definitely influenced the gravity of this galaxy, but I'm not seeing it being disrupted in any way. It just kind of shot right through it. I think it actually did do something. I'm noticing something in the center here. There's a little bit of a gap. Let's try this again. Let's slow this down and we'll fire another one through. And we'll do it without all of the trails. So that way we can see it a little bit clearer. So launch. Just launch this again. And we'll have it go right through here. And it's probably gonna happen really quick. Or maybe not so quick. Okay, that's good. Okay, and then... I can't tell if anything happened. I don't think anything did happen. But what if we take a bigger galaxy then? whoosh. It's gonna go right through the center. Although, hold on here. It it didn't really affect the Milky Way, but it definitely affected the small cloud. We'll try this experiment. We will take the Milky Way Galaxy and we'll have just its own black hole orbiting the Milky Way. And yeah, I'll keep it in orbit. I'll keep its own black hole in orbit around here. Let's actually do binary since they're roughly the same mass. We'll have the black hole just kind of going within here, around like, the outer bands of its own galaxy. And we'll see if this ends up doing anything weird. Any weird dancing happening. Oh, okay. Uh-oh. It's moving towards the center and... And ladies and gentlemen, we have just created our first black hole launcher. We'll try this again with multiple of these black holes. Let's just put tons of them in where it will just overpower the center of the galaxy. Where one Sagittarius A is going to be nothing when you have many, many Sagittarius A's invading the galaxy. What could happen here? I'm going to wild guess, simulation problems. Maybe they'll just all collapse in the center and then start flying out. Just a hunch what's probably going to happen, but I want to know what would happen in the... Oh, there's one... And yep, another one launched. Yep, they're all launching. Yep, launching. Gravitational slingshot. Oh, there's another one going. There's another black hole going. Yep, goodbye. I can't comprehend how... they're moving faster than the speed of light. Let me click on this Sagittarius A right here. Just the speed it's going at right now. How fast are you going? What's your current velocity? Motion. Speed, 150 kilometers per second. Oh, well, yeah, we have to take into account we're looking at a time step of millions of years per second. So I guess we're probably not breaking any laws of physics right now. I love this game. One thing just leads to another. All right, we got faster than light travel. What would happen if we took a single baseball and launched it faster than the speed of light towards Earth? What kind of time step are we gonna need for this? Speed of light, we're talking pretty instantaneous here. All right, this is borderline paused. What if we had an asteroid? A random asteroid. Whoa! See, now that's where it really shows. Random asteroid going at light speed. Boom! A huge crater like that. I feel like it would still be bigger. I think it would completely vaporize the moon if an asteroid traveling at the speed of light hit a celestial body. You have to think of the kinetic energy within that. It would completely shatter the planet. Think of if you shot a water balloon with a bullet, the thing would explode because the bullet's moving really fast. This is fast. What? Well, why did that one be so weak? That was still speed of light and does a measly crater like that. Then you had these two right here. At least these two had some self-respect. This one was just like a pin needle. Well, how about this? What if we just clipped the moon of Pluto? Oh, that's not helpful. So there's Pluto going at the speed of light. God damn. All right. So now, and that should heat up the moon. Now, what is the velocity of the moon now? Now that Pluto collided into the planet and just skid on by. We have the motion of the moon. It's currently going at 260,000 kilometers per second, so wow. That's a fun set of experiments. New galaxies leading to a bunch of light speed experiments. Good old spiel on gravity. This has been fun. I hope you guys enjoyed. May more experiments come in the future whenever I can think of something, if you guys can think of something. And yeah, if we have plenty of other old Universe Sandbox videos, feel free to check them out. Hope you guys enjoyed, and I'll see you all later. That's cool. That's actually really cool. They just keep transferring their mass. So this is the mass of five-ish Jupiters. It just keeps transferring it. This one keeps growing, or it's staying at 9 Jupiters, but oh.